Hey there, chemistry nerds. I'm going to help set you up for what I do all the time for your labs because I love you. I do this for you all the time. I want to review really quickly as you're looking at section, I guess it's 12, about measuring concentrations of solutions. Now, you know the saying, the solution to pollution is dilution, right? So I'll show you how that works when we set up these solutions for you to do in the lab. And you do have a lab coming up. It'll be your last lab, and it'll be about diluting things or about making solutions and how quickly things happen, depending on the method that you use. But I think you know stirring and smashing and heating and things like that help things dissolve faster, like coffee. Okay, so 3 that are listed there in your book, and they have different applications. My father-in-law worked for the Department of Agriculture for the state of Oregon for 30 years. And so he did lots of work in chemistry in the area of solutions, analyzing samples for pesticides, and they'd grind up chickens and analyze them for what was in their feed so that things stayed within the stated guidelines for things that people are allowed to spray on stuff to kill bad things. Anyway, they had a lot of guinea pigs in their place too. Did you know the guinea pigs float? Yeah, I think I got a story about that. Okay, well, measuring concentrations comes in 3 different forms. The one that we use most of the time in chemistry for our labs and whatnot is molarity. And molarity is given the symbol M, and it is however many moles of a solute, that's the part that's like the powder that gets dissolved, in 1 liter of solution. The solution, again, is that solute mixed with water, basically. Okay? Pretty much for all of our stuff in the lab, it's like mixing with water to create the solution. So when I say something has like say it has a molarity of 1.2 molar solution, let's say that it's sodium chloride. You know, this is a salt water solution. If I have 1 mole of this solution, it contains in it, or sorry, if I have 1 liter of this solution, it contains 1.2 moles of sodium chloride. How do we go about figuring how much that should be? Well, we're just going to use the molar mass of sodium and chlorine, add them together, and then multiply by 1.2. And we'll put in that many grams of sodium chloride into water. And they always say in the book, enough water to make 1 liter of solution. I'm going to demonstrate how I do that here in just a minute. Secondly, molality. And the book describes the situation for this one. It says that we would use molality with boiling point elevation and freezing point depression types of problems, and that would be when you add stuff to water and like antifreeze, let's say. You can have a liquid in your car at temperatures lower than 0 Celsius and the thing doesn't freeze. Very important in very cold places. So they use molality measurements there. Moles of the solute divided by kilograms of the solvent. So they're like comparing how much is something in a certain amount of weight by weight, kilograms. Thirdly, this is the one that my father-in-law would use often, parts per million, and sometimes we do parts per trillion. Get a report every now and then, or at least I did when I lived in town, of the various wells around town where they get water, and they'd have to test those for heavy metals every now and then, and they give you a report as to which metals were in there and in what proportions. And the way that they measure that is grams of these solutes, like these metals or compounds that are in the water, the groundwater normally, divided by 1,000,000 grams of the solution. Again, this one's comparing weight to weight. How much of the weight of this solution is the metal, and compared to 1,000,000 grams by weight of this thing. As you're doing the calculations, I think on Monday, on those, it's like sample problem A, I believe. If you ever get spitting out of your answer thing e to the negative 6, like times 10 to the power of negative 6. That's your ppms. So it should pop out really nice. You get an answer like 2.3 e to the negative 6. That's 2.3 ppms. So if you ever want to talk to Jerry Vandy Koppel about ppms, he'd be happy to tell you some stories about adventures in the lab. Okay, I'm going to turn things around here and set up my table, and I'll demonstrate for you the way that I would go about doing one of these types of problems for you as I get things ready for you for the lab. Acids, bases, salts. We're going to combine stuff and get precipitates. We're going to see how these things react. They got to be in the right proportions. So let me get that set up and demonstrate how I do my work. Alright, now I'm over here. So I got myself a couple of things out of the lab. I was trying to decide which one to do. I picked these two because I have a whole lot of them. And I'm going to make up a 0.500 molar solution of these two. Similar to what we've got in the book. I've got ferrous sulfate, FeSO4, but it comes with 7 waters, like our copper sulfate problem. And I've got potassium sulfate, and it's just all by itself, K2SO4. And doing the math, I would need to use a lot less of this than this one. So I'm going to go ahead with the K2SO4. Step 1 of this is to figure out the molar mass of K2SO4, because I want to know how much I should add to my solution. So I went to my periodic table and I listed off their molar masses individually and added them all up. So if I was to put 1 mole of this stuff in the solution, I would get 174.27 grams of it, weigh it out. Add it to enough water to have 1 liter of a solution. Now today I'm only going to make half of a liter. Okay, so right away I'm going to have to divide this in half if I wanted a 1 molar solution. So 174.27 divided by 2 is 87. Okay, so if I want half a mole, 1/2 a mole, that will be 87.135 grams. Right. Now the other thing that I'm doing is that I only want to put half a mole in half a liter. I don't want to put half a mole in a full liter. I want to put half a mole in half a liter. So what I'm going to do, I'm going to have to divide this in half again, so that I'm going to only put half a mole in half of a liter. Make sense? So I'm going to divide by 2 one more time, and my magic number that I need to weigh out for this solution, hang around 2 decimal places here, 5, 8. 845, sorry, 43.5. Now, to show you the process for going about this, you don't just dump it in a bunch of water and stir it, because you really don't know exactly how much water that you're going to need for the process. I've got here one of these flasks, and I filled it up with exactly, or as really close as possible, 500 milliliters of water, half of a liter of water, okay? And over here, I've got a 500 milliliter flask. And it's got a line there so I can get as close to that line. What you do with these types of things is, first thing you do is you're going to pour some water into the bottom of the flask. The reason why you do that is because you're going to pour a powder in there and you want it to start doing some dissolving. You don't want it all to be caked at the bottom. So you're going to put some. Okay? I did probably put maybe 100. Maybe 100. Next thing I'm going to do is I'm going to weigh out the right amount of the stuff that I need for my experiment. I'm going to do it on some, filter paper so I can shoot it in there. Nice and easy. Put my paper on there and tear it, and then I'm going to use the potassium sulfate, and I'm going to use gloves, even though this thing is super, super safe. It's like as safe as regular salt. So I'm going to glove up for safety here. Get out the scoop deal up. And I need 43 about 43.6 grams of this stuff weighed out on the scale. So here goes. A lot. 30, 43. A little bit over. Pinch off. There we go. 43.6. Okay, so I start off by putting some water in there, but obviously not enough. Unglove it now. Probably, I don't know, stupid or not, but there we go. And we're going to funnel this stuff down into the some water. Oops. What else is rubber policeman for? When you make messes, right? Got gloves on again. Alright. Mostly the rest of it. Pretty safe this time. Alright. So I'm going to start the dissolving process. I want to get most of it to kind of do its thing here before I pour more water. It might be that this won't all dissolve with the amount of water that I got in here, but now I've got all of this solute in here, and I just need to add enough water to make 500 milliliters of this half molar solution, right? So I have, if I had a full liter of water, I'd have half a mole. I only have half a liter of water, so I need half of that. All right, that looks pretty good. We're going to top it off by pouring enough water in there to get it close to that line. Again, we really don't exactly measure the water. We just pour enough in there to get us up to that 500 milliliter line. And we call it good. Oh, the anticipation. All right. Close. Maybe we want to use the stirring rod. Pour it down the stirring rod. Really close to it. A little bit more. All right. Pretty good. So then we just stir like crazy, or if you're in a really nice lab, you put it on a hot plate, which has you drop a little magnet thing in there, and then turn the spinner thing on, and it'll spin, and it'll stir itself. And then just there we go. And we know now that we've weighed it out, we know that we've got enough in here to give us concentration of, if there was 1 full mole, we would have half of a mole, sorry, 1 full liter, we would have half of a mole in this solution. We only have half of a liter, so we need only a half of that. And once it's all dissolved, some things take longer than others, and we can use it with fairly accurate calculations. If you're doing like a drip drop lab, if you look forward in the acids and bases, they have a lab in there where you actually do that. If you take a chemistry course in college, no doubt you'll do a drip drop lab. I was helping Enrique with one of those. But yeah, that's how you make a solution. You need to know molar masses. You need to know what your molarity needs to be and how much water you're using, but that's how you do it.